Welcome. On this lesson, we'll be discussing the law of sine. So let's get started. Before we actually state the law of sine, let's just refresh some concepts from geometry. In this question, we're asking, do we have enough information to show that the pair of triangles are congruent to each other? Well, let's take a look at case by case. By looking at the images that we do have here, notice that we have congruent angles and congruent sides. We can see that this side is congruent to this side of the other triangle. We can also see that this angle, which I'm going to call it angle 1, it's also congruent to this other angle, angle 1. And we can see that this angle, angle M, it's also congruent to this angle P. Now, at least the order that we can use to read the congruent angles and angle sides, that will be angle, angle, side. Angle, angle, side, angle, angle, side. And notice that they kind of follow the order of angle, angle, side. And if you recall from geometry, this is one of those combinations that we can use to show congruency among triangles. So, at least in example 1, we can show congruency among triangles, on congruency of triangles, um, due to angle, angle, side congruency theorem. If we take a look at example B, we can see, let's just state what angles are congruent to what angles and what sides are congruent to what sides. We can see that angle A is congruent to angle D. We can also see that AC is congruent to DF. And we can also see that C is congruent to angle F. And if we take a look at the order or the way that we follow stating the congruent angles and angle sides, you will see that we have angle, side, angle. So angle, side, angle. And remember that if angles and sides are given to you using this order, angle, side, angle, then this is one of those ways that we can show congruency among triangles. So if you recall from geometry, we can show congruency of triangles if we use angle, side, angle congruency theorem. But what's going to be more important is example C. Because now, if we take a look at example C, we can see that this side is congruent to this side. And we can see that this side is congruent to this side. Oops, sorry. And we can also see that angle C is congruent to angle F. And if we follow the order that we do have here, we can see that the side angle. And if you recall from geometry, this is a special case because we cannot use side angle, because if we take a look at the order, side angle, side angle. If we follow this order of side angle, then this is just one of those ways that we cannot show congruency among triangles. So in this case, we can say triangles are not congruent. So recall that there's many ways that we can show congruency among triangles. We could also use side. But we want to concentrate on these three specific cases: angle, side, angle, side, angle, to show congruency. And recall that side angle is not one of those ways that we can use to show congruency among triangles. So let's put this idea on the side because we're going to come back to it. And let's actually start introducing the idea of the law of sine. Well, first, there are different ways that we have discussed to show or to solve right triangles. One of them being the Pythagorean theorem. You can definitely use the Pythagorean theorem to solve right triangles. So now we're going to be discussing a technique that we can use to solve triangles, which we define as oblique. And recall what an oblique triangle is. An oblique triangle is a triangle that does not that does not have an interior angle with the measurement of 90 degrees. Because if it has a 90 degree, an interior angle whose measure is 90 degrees, then we call that a right triangle. So an oblique triangle is pretty much a triangle that is not a right triangle because it just doesn't have an interior angle of 90 degrees. So keep that in mind. The law of sine is going to be a tool that we can use for any triangles because we have different ways to solve right triangles. The most important one being the Pythagorean theorem, or we can even use what have we discussed in trigonometry using SOHCAHTOA. But now we want to concentrate on situations where perhaps our triangle is not specifically a right triangle. And for that, we're going to use the law of sine. But before we state the law of sine, let's see, what do we need to use the law of sine? Well, in order for us to use the law of sine, we either need two sides, the measurement of two sides, and one angle, or we need the measurement of two angles and one side. Because in any triangles, there are three sides, which in this case A, B, C, and there are three interior angles. So angle A, angle C, and angle B. So if we have the measurement of two of the sides in the triangle and one angle, then we have enough information to use the law of sine. And also, if we would have got information about two angles and one side, then we can use the law of sine. But there's a little asterisk on this because we got to be careful with the way that the information is given to us. Because if we know the measurement of two sides and one angle, we have to be careful because if the two sides and the angle and the information about the triangle, if that is being given to us using the order of side angle, then we cannot use the law of sine. Or we can use it, but there's a little asterisk on that. So if we've been given two sides and one angle, just make sure that it doesn't follow the order of side angle. And if you've been given two angles and one side, just make sure that it follows either angle side or angle side angle. So that's just something to keep in mind because side angle is not a way to show congruency among triangles. So there's a special case for that. So just make sure that it doesn't follow the order of side angle when you've been given information about two sides and one angle. And if you've been given information about two angles and one side, just make sure that it follows the order of angle side and angle side angle. And the most important thing is, what use does the law of sine have? Well, the law of sine is a tool that we can use to solve or to find measurements of sides or angles in a triangle. So the law of sine is going to be a tool that we can use to find measurements of either the sides of the triangle or either the angles of the triangle. So keep that in mind. Okay, so we have introduced the law of sine. We have said, well, when do we need it? What do we need it? What's good for it? So let's actually state it now. So in any triangle, ABC, with measures or with sides ABC as well, which I guess we're talking about this triangle right here. So notice that this triangle has angles ABC and side measurements of ABC. In any triangle with those, I guess we're going to use that notation, but for any triangle, the law of sine states that if I take a look at the line segment A, so if I take a look at line segment A, and if I divide it by the sine of angle A, which is literally the sine of the angle that is opposite of little a, that's going to be equivalent to side B over the sine of angle B. In addition, that's still going to be equivalent to side C over sine of the opposite angle, which is big C. And this is what we state as the law of sine. A over sine A, that's equivalent to B over sine B, which is equivalent to C over sine C. And also, this is not the only way that we can write the law of sine, because we could have also stated this as just being sine of A over little a, and that's equivalent to sine of B over little b, which is also equivalent to sine of angle C over side C. So there's two ways that we can write the law of sine. Which one is correct? Both of them are correct. Which one do we use? Is whichever you feel comfortable with the information that you've been given in the problem. But just very important, because when we use the law of sine, make sure that your calculator, it's in degree mode. I cannot stress this enough. You can set it up correctly, you can solve for the side correctly, but if your calculator it's in radian mode, that might be a problem. And again, how do you set up your calculator in degree? Well, you turn it on, you press mode, and you have to make sure that it's in degree mode. Now that it's in degree, then we can continue. So just make sure that when you're using the law of sine, your calculator is in degree mode, because we're going to be talking about angles, and usually this type of angles are given in measurements of degrees, not radians. All right. So this is what the law of sine is. This is how we state the law of sine. And now let's actually use it now. So let's take a look at one example here. Let's identify what we know about this triangle. And let's identify what we want to do with this triangle. It says for the triangle in the figure, angle C is 102.3 degrees. Angle B is 28.7, and side B is given to us by 27.4. But before we use the law of sine, ask yourself this question: do I have what is required? Well, I have an angle, I have the value of two angles, and I have the value of one side. So yes, that's definitely something that we can use, because this is one of those combinations that we can have. If I know the value of two angles and one side, then we can definitely use the law of sine, which is what we have here. We have the measurement of two angles and the measurement of one side. So we're good. But now, very important, take a look at the order here. We have angle, angle, side, which it's okay, because that's one of the cases that we can use the law of sine, because it follows the angle, angle, side format. Okay, so two angles, one side, and it follows angle, angle, side, so we're good. Okay, so now we know that we can use it. So let's start by stating what the law of sine says. So the law of sine states that if I take a look at side A and I divide it by the sine of A, that's going to be equivalent of B over sine of B, which is going to be equivalent to C over sine of C. And again, what we want to do here is to find the remaining angles and the remaining sides. But if we take a look at the way that the problem is stated here, notice that I know side B and I also know angle B. So I definitely know the value of this ratio. So this ratio is going to be 27.4 over sine of 28.7. But now notice that I also know angle C. So I can definitely find the sine of C. And if I set it up correctly, out of these four pieces, I know three. I know B, I know sine of B, I know sine of C, and I don't know C, which is one of the unknowns. So even though you have three ratios that are equivalent to each other, under the law of sine, you only want to use two. And you want to use the ratios that will give you one of the unknown. So If you want to find side C, then you definitely need to know an angle and its opposite side, and the angle that is opposite of the side that you want to find a measurement of. So let's set this up. Let's set this up. So what is side B? So that would be 27.4 over sine of B, but I know that B is 28.7. So that would be the sine of 28.7. And that's going to be equivalent to little c, which is side C, which we don't know information of, over angle C, or the sine of angle C. And now we can cross multiply and find the measurement of big C, which I'm going to skip some of the computation. And now you can see that C is going to be equivalent to 27.4 times the sine of 102.3 over the sine of 28.7. Okay. And this might look a little bit weird, but I mean, it might not look nice, but this is definitely something that we can use our graphing calculator for. So let me get my graphing calculator. So here it is. And let's just plug this in. And let's actually, and again, make sure that your calculator is in degree mode. So let's just plug this in. So we got 27.4 times the sine of 102.3, and all this. So let me press enter. And this is going to be divided by the sine of 28.7. So now notice that we have a measurement of side C. So now I can see that side C, it's about 55.75. So now I know what angle C is at. So I know that this side, it's equivalent to 55.75. All right. So what exactly are we missing? We're missing, okay, so this work was for side C. The only thing that we're missing is just angle A and side A. But notice that we cannot use the law of sine yet because we're missing A and side of A. So we're definitely missing the whole ratio here. But recall that in any triangle, the addition of the interior angles is equivalent to 180 degrees. So we can definitely solve for angle A. And angle A, oops, let me bring this down. Angle A is going to be equivalent to 180 minus 102.3 minus 28.7. Because recall that if you add all interior angles, that's equivalent to 180. So let's find that out. So 180, so 180 minus 102.3 minus 28.7. That's equivalent to just 49 degrees. So now I know the measurement of angle A. Angle A is going to be equivalent to just 49 degrees. And now notice that we have enough information to find little a. Because now, if we come back to the way that the law of sine has been stated here, I'm looking for little a. But I know angle A now, so I can definitely use this too now. I can say little a, over the sine of angle A, which we already found out to be, not 47, but 49. Sorry, that looks like a 99, so let me just fix that. Okay. So that's 49. That's equivalent to little b, which we found it to be 27.4. 28.4 over the sine of b, which is going to be the sine of 28.7. And now we can definitely solve for a now. Because now to solve for a, again, we can cross multiply and get that a by itself. But due to time, let me just write the expression. So a is going to be equivalent to 27.4 times the sine of 49 over the sine of 28.7. And again, once you have it in this way, then we can definitely use our graphing calculator for that. So let's actually pull our graphing calculator, which is here. So now let's just set it up. This is going to be equivalent to 27.4 times the sine of 49. So I think I'm missing, yep. And that is going to be equivalent, that's going to be divided by the sine of 28.7. So now we know that side A, it's equivalent to 43.06. So let me just write this down. So 43.06. And now notice that we have solved the triangle because we definitely know the measurement of all the interior angles and we definitely know the measurement of all sides. And this is one of the ways that you can use the law of sine to just solve or find the measurement of sides and find the measurement of interior angles.